Hello, my name is Higashino from Z Engineering. For the past 42 years, we have been working with steam traps. During that time, we have seen steam systems in many different factories. This YouTube channel is not meant to defend or promote orifice traps. Instead, we will talk about the real problem that's actually occur in steam system in the field, and how we have tried to find answers to those problems through our work on site. That is what this channel is about.
In the previous episode, we discussed the development of the multi-orifice lotus trap. Today, I will talk about another design, a multi-stage trap developed specifically for tire curing presses. This trap is called TS-1. For a long time, people have said that orifice traps cannot be used in tire curing machines. And in fact, I was one of the people who proved that statement. Single orifice traps did not work. More than 20 years ago, we installed single orifice traps in a tire factory. But during cold start, the temperature did not rise properly. Eventually, those traps were removed. The cause was not the structure itself. The real problem was that the operating range did not match the variation in condensate flow. This graph shows the operating range of the orifice trap we installed at that time. During normal curing operation, condensate flow is stable, and the amount of condensate falls within the operating range. So, under those conditions, there is no problem. However, right after a mold change, the situation is different. Both the curing press and the mold start from a cold condition. In other words, a cold start occurs immediately after mold replacement. At that moment, condensate flow increases rapidly, and that flow exceeds the operating range of the orifice. As a result, the temperature of the heating plates rises very slowly. Since that time, many engineers in tire factories have believed that orifice traps cannot be used for curing presses. Among tire plant engineers, this idea became almost common knowledge. So, how much condensate actually appears during cold start? This is not something that can be calculated on a desk. So, we went to the field, a tire factory in Tianjin, China. We installed a steam flow meter on the curing press, and we measured steam consumption minute by minute during mold change. This graph shows the measured data. The vertical axis is steam consumption per minute. The horizontal axis is time. We collected data with two traps, a TLV trap, and our TS-1. The important point is here. During the first few minutes after cold start, condensate generation was more than 3 times higher than during normal curing. Now, consider this question. What happens if we design a larger orifice to handle the cold start condition? This graph shows the discharge capacity of a larger orifice. Yes, during cold start, it can discharge the condensate. But during normal curing, the condensate flow falls below the operating range, which means steam leakage occurs. This is the limitation of the single orifice design. In a single orifice trap, the only design parameter is the orifice diameter for a given differential pressure. But a multi-stage trap is different. We design the number of stages, the size of the orifice plates, the orifice diameter, and the position of the orifices. In general, the more stages we use, the wider the condensate discharge range becomes. If we know the condensate flow conditions, we can design the necessary operating range. The data from the Tianjin tire factory became the basis for the design of TS-1. This graph shows the discharge capacity of TS-1. As you can see, both cold start and normal curing operation fall within the usable operating range. In January 2020, 400 TS-1 traps were installed in the Tianjin tire factory. Since then, they have operated without a single problem. The maintenance manager told us the traps operate without maintenance and without failure. After 1 year, the regular trap inspections that had previously been done every 6 months were no longer necessary. Trap management became much easier. In addition, the energy manager told us something interesting. After switching to these traps, steam consumption decreased by about 14%. Recently, in some tire factories, you may see traps described as nozzle type or venturi type. However, many of these designs use the same basic principle as an orifice, which means the fundamental issue of operating range does not change. When condensate flow changes significantly, the same problem appears. We will discuss this topic in another episode. In the next video, we will discuss another common question from the field. Do steam traps leak steam? In reality, the issue is not whether steam leaks or not. The real question is how much steam is leaking. In the next episode, we will talk about how difficult it is to measure steam leakage as a quantity